Welcome to the next episode of The Front Row, brought to you by Martin Logan. Today, we're going to continue our conversation on HDMI with James Chen from Kordz. But before that, let's have a word from our sponsor.
Bass that hits hard, fits anywhere, and sounds like it belongs. Martin Logan's Dynamo and Abyss series subwoofers deliver high performance and compact elegance with stunning precision and control. Martin Logan, bringing you truth in sound since 1983.
Welcome into the conversation where we are again joined by James Chen from Kordz. James, you had an event this past weekend, and we go to CEDIA next weekend, all three of us, which at the beginning of first time I went, I'm like, oh man, CEDIA. And now I'm like, oh no, CEDIA. And it grows on you and then it takes away. So how have you been? It's been a few days since I last talked to you. How have you been?
I am doing awesome because right now my team is building our expo stand. And because I have a podcast, I unfortunately cannot attend to lift heavy things. So I'm doing great.
Because I have other things to do, I cannot do that. Yeah.
Well, obviously, obviously this is much more important than lifting heavy boxes and assembling, odd bits of geometry.
Maybe not to the other people that are lifting heavy boxes and assembling odd bits of geometry.
Oh, they love it.
Oh,
they love it.
That's what you tell
yourself. I
took them out
for chicken wings last night.
All right. You're a good boss.
Applied them with alcohol.
Gave them ample lubrication,
I even allowed them to sleep in till 9:30.
Oh, man.
But they've had an extra hour and a half sleep.
Look at you. A generous man. Eric, how have you been?
Stop.
I've been good. Today's one of those days, though, that everything just has not gone the way that I was planning on it. Like doing some of setting up a projector and stuff, taking down my projector. It's just it's one of those days where you think you have it working and then it doesn't work, and then it just ends up being a mess. And so yeah, hopefully this podcast is a lot better than.
So you're like the living embodiment of HDMI.
Exactly.
Yeah.
Sometimes it works, sometimes it doesn't.
It works. Now, in a good, well set up signal chain, it should work every time.
That's true.
Now that leads me to James. You have a correction from last stream, right?
Yeah. So we threw up a whole lot of numbers, and obviously, HDMI is this really simple thing with no acronyms. No, I'm just kidding. So, we're full of terminology and things like that. And we referred to things yesterday, last time I had a brain fart. So we referred to something which we should call milliseconds as microseconds. And I made Ryan also follow me and say microseconds. So we actually meant milliseconds.
You're smarter than me, so I followed you.
That is, well, depending on what the definition is. On what?
Well, at least in HDMI. So I followed suit, and I thought initially, I'm like, man, microseconds, that's really short. But
yeah, that is really
man
short.
knows his stuff, so I'm gonna go with it. Yeah. But I'm glad
we could change the topic and talk about Ascendo subwoofers, physical experience on Ascendo subwoofers, and I think you would win on that one. Maybe.
But we'll find out. Today's not about that. Today's about HDMI, so you're gonna win the day on that for sure. So where did we leave off?
Well, last time we talked about compliance, and we talked about mislabeling and things like that. So today we want to kind of continue on our cable path, and we want to talk about what is really happening within an HDMI. We'll finally get to look at what an eye diagram is. And then we might, if we're lucky, we'll get into cable construction. And Ryan, I might even allow you to ask me some questions today.
Oh, man.
As opposed to talking over you.
Oh, I have a tendency to talk over you. I think it's the other way around. So, but maybe we can get there.
Yeah.
I'm just excited about, as I've said in the past, to talk about HDMI. So sorry, I'll turn it over to you.
So what's really happening within an HDMI cable? So with the launch of HDMI 2.2, which we discussed in the previous episode, some of the features, and a reminder to our audience that some of these features are very much optional, and they may or may not be implemented. But with the advent of HDMI 2.2, HDMI is now, supporting 100 times what we're getting in gigabit Ethernet. I'm not talking about megabits per second here. We're talking about gigabit Ethernet, and we're not getting gigabit Ethernet 100% of the time. Ethernet, as we know, the internet, as we know, is buffered, and we have wireless access points and things like that cause the disruption. Whereas with HDMI, yes, we have various different frequencies, but the maximum frequency is happening in real time. 96 gigabits per second is about to be launched with us. Currently, if you're gaming, running 4K 120 hertz, you are using the current generation, or the previous generation, which is 2.1, at the maximum 48 gig rate. And if you're using DSC, which is direct stream compression, the 3-to-1 compression that can be implemented in HDMI, even under the 2.1, you could be running up to 128 gigabits per second already. So this new standard is going to bring a lot of things, and we expect it to happen in real time, i.e. no jitter, no pauses, no stutter, audio and video aligning at the same time. One of the things we also know is that we have lots of problems with long cables. When we run a short cable, like a 1 meter or 2 meter, yeah, sure, there's not too much that can go wrong unless you're building very, very complex systems, right? At that point, even those short cables are very additive to the jitter and the information loss, the packetization loss, the packet loss over the course of the entire system, and that causes handshake issues and signal issues and things like that. But a lot of us experience a lot of problems with long cables. And the thing to note about the long cables is whatever is happening in long cables is also happening in short cables. It's just not as much. And the reason we know this, and we touched on this last time, is that we are doing digital transmission over distance, which means we're doing voltage over copper, which means we're doing analog signaling, and analog signaling has very steep drop-offs as we go out further. It's kind of like a high frequency driver, in a loudspeaker. There's a real sharp roll-off when you get to the extremes. So here are some real facts in terms of what to expect in real life in terms of cable. So with 8K at 48 gig, we've now got fairly reliable HDMI cables. And I don't mean extenders and HDBaseT devices. I mean 48 gig native active optical cables. They can work pretty much up to 100 meters now, right? But they cannot meet HDMI compliance, because part of ultra high speed compliance is also compliance to EARC, the enhanced audio return channel, which gives us 32 channels, 24-bit, 192 kilohertz signal return from the sync device, so the TV or projector. Some projectors have got audio built in, back to your AV receiver, so the AV receiver can work through the app that you're streaming off your TV. So it's very important that we understand that, and there are ways to get around that. So we can use EARC extenders to extend that range.
Mm-hmm.
But one of the things to understand is cables need to support every feature. Electronics deliver optional features. So in order for a cable to support EARC, the maximum length at the moment, it's pretty difficult to achieve beyond 20 meters.
Yeah. But it's interesting that a lot of cable manufacturers will still say that they support EARC on a cable that well exceeds that.
Yeah. So this is really dependent on the cable.
Yeah.
And the device.
Yeah. And I
Um,
totally agree with what you're saying, because in practice as a dealer, I've run into this quite a bit where you'll be like, oh, this is going to work with eARC, and then it does not.
yeah. So at 20 meters, in my experience, which doesn't mean it's every case. There's always exceptional cases where it exceeds what I know from engineering, of making millions of HDMI cables now. Not me personally, but designing and engineering and stuff. So a 20-meter HDMI cable, in order for it to support eARC, that twisted Ethernet channel pair inside is running at around about 18 gauge, right? So by the time I make a jacket around that, shield it, and things like that, it's actually quite stiff. It's the cable is getting close to the diameter of your little finger. Getting close. It's not exactly not as thick, but getting close. Then you're dealing with a cable that's very, very stiff and has a very, very wide bend radius, because you've got other conductors in there as well, which makes it very difficult to install, which also makes it, you're starting to have the cables actually levering the HDMI socket
Mm-hmm.
and applying pressure on the circuit board. Over time, that could decouple.
Yeah.
And that's, kind of like the worst case scenario, where you have to replace your device not under warranty. But for our audience, a more simpler experience is the HDMI cable being so stiff that it's pushing your projector out of alignment.
Yeah.
It's
Right.
true.
So you can't tighten the bolts enough when you've got something that's applying constant pressure. And if you overbend that cable, you've now changed the resistance characteristics in the cable and caused it to drop out of specification, which is going to now increase the noise that's going into the cable. It's going to increase the jitter aspect, and which we'll go into, and you will have a worse experience. So these are some of the things that we've got problem in long cable. And if we want to go further than that, then you need to go even thicker. So we're going away from the usability aspect of it to something which is just really impractical. It's very expensive to make the product and even get it compliant. And remember that compliance now is about getting every single HDMI cable length certified by HDMI.
Right.
The flip side
Okay.
of that is there is a practical aspect as well. Someone wants 48 gig to 75 meters to a device that's remote, like in an outdoor entertainment area. So you've got that. It's got its own speaker system. You're pushing. That's why we do distributed audio systems. We're pushing the content to the TV as opposed to try to use the TV as a source device. So in that aspect, you get a set-top TV, whatever your device of choice, say an Apple TV, and it pushes out over that distance. Then we don't have this audio-related issue, because there's a way to design a system around this when audio return channel is not possible. But you want 4K because you've got a 120-inch screen by the pool. Some of these big LED walls that come out of the ground or are mounted to the side of a wall, which are all weather devices. So there's a way to actually design around these systems. So the final thing about this, and it's kind of like, just to complete, the spec doesn't actually define length on limits. It actually just defines the performance. So HDMI is kind of like, well, we don't really care how you do it. We just want to know that it's done by the specification. You can output what we specify at whatever distance. And you can use external power to do so, but that power needs to be compliant to the 5 volt.
Okay.
So no, you cannot inject 12 volts into the circuit. No, you cannot increase the voltage to beyond the device. and we touched on this with sync devices before last time, is that if you have over voltage in a circuit, given that the sync device starts the HPD and completes the circuit for DDC activity, that you could actually overcook the electronics on both sides. I mean, it happens over a long term, but you know, if you've bought I know good projectors these days, you're looking at $10,000 plus. And I don't have a spare $10,000 lying around every 2 years to replace a projector.
Right.
I'd rather buy a car. So, you know, those types of scenarios. So in the past, to get around this long length thing, there was a mode that was created by Sony called long length cable mode. And long length cable mode was Sony's genius piece on, well, voltage is down, there's a limitation in terms of the output. We will just boost the equalization. We will put some smarts in there in order to unpacket the signal to give us a more secure performance.
Mm-hmm.
And we recognize, for the very first time, we now recognize that projectors are going to be used and screens are getting larger. And typically, AV receiver sits underneath the screen, or you know, in a rack to the side corner, and the projector is well away. Sony created this, and you know, it kind of gave us reliability. So other brands started implementing this, and the flip side of this is when we use short cables that actually didn't contribute enough loss of signal over distance, delivered over voltage to the sink, and so we got something called EQ saturation. So in fixing something, you caused another problem.
This is the way. This is the IT way.
This is the way. So longer cables no longer some longer cables don't work, and now some shorter cables don't work. And the industry labeled that length limit at around about 2 meters. So there is this thing floating around where people are saying, okay, don't use a cable that's 2 meters or shorter. That is not correct. Personally, my opinion, that is not correct. The reason why people say that is because they cannot predetermine where you're getting your cables from. What I mean by that is, well, the whole analog thing, well, the thicker the cable, the better. You have less loss because the copper wires are thicker. Well, now we've got a situation that we've created that we're not having enough loss. So those really thick, high performance, audio, esoteric cables that you paid thousands of dollars for, well, they now don't work. In fact, if I just went out and bought a piece of crap, I plugged it in, well, it now what why does this $5 piece of junk work and my $2,000 XYZ, which was giving me great audio and picture, now not? So this completes one of the stories. If an HDMI cable is well balanced and compliant and certified at the length, most of the time it should work. If the company, and that's why we, you know, good organizations will vary the actual diameter of the cable, because when we're doing racking when we're doing wiring in a rack, we actually don't want more stuff. There's more and more technology in our rack, not less. Devices are getting smaller. We're putting more stuff in. Our homes are not getting bigger. Well, at least the staircase where the rack is going is not getting bigger. So we're kind of stuck in this situation where we really truly need to find a solution that provides excellent shielding, excellent bend radius, thinner cables that are well constructed, that deliver reliability that are certified. And the final point I want to make to cables is when you plug in the long length AOC, remember in an AOC, generally speaking, there are 4 optical conductors for the TMDS and FRL. Everything else is copper. So that everything else is also subject to noise, electrical noise, magnetic interference, additional devices, voltage fluctuations. If you want to see that happen, just go to your rack, plug in a blender to that power supply and run it. See how successful you are going to be, delivering your delicate audio signal. Don't do it for long.
James has inadvertently just blown up everybody's all the equipment in somebody's rack, just gone. Don't do that. Don't do that. Nobody test that.
All right. Let's go to the next slide. So these are the types of, so one of the things I want to start getting into is you guys buy product and you go out there and you trust the brand, and the brand may or may not make those cables.
Mm-hmm.
But that doesn't mean that the brand doesn't have a quality assurance process for the products that they buy.
You're
as
talking
a manufacturer.
about white labeling.
Yeah, I'm talking about white labeling, or there's plenty of brands out there that are very well known, and making cables is not their expertise, and so they source like I don't know, a well-known TV brands or well-known Blu-ray player brands, right? That then include the cables inside the boxes. And I'm not saying that the included cables are not good, nor am I saying that they're not compliant. But what I'm saying is that is not their expertise. They don't own the cable factory that makes the thing, but that also doesn't mean that they don't have a quality assurance program to ensure that the products are good. But I want to point out the different levels of testing that cable manufacturers do when you actually buy any cable, whether it's an HDMI cable or USB cable or DisplayPort cable. There are different tests, and based on those tests makes the product cost more. That was really bad punctuation. So the cables cost more based on what kind of testing you put on there, and whether you have your engineers on there when the cable's tested, whether you have a quality assurance company, whether you have fire and safety compliance, and how you test. So the highest level testing that's available is the HDMI compliance test. And the HDMI compliance test is done to cables that want to pass HDMI ATC. It's very rare that cable is then tested again at that level. Once it passes, we go into an area called self-test, where usually the manufacturing partner is allowed to self-test. And they will go, okay, well, we've got this ABC brand, we've got this platform that passed HDMI ACC at this certain length, and we can offer you a version of this. An important word in that is a version of this.
I was going to say,
what does a version of this mean?
Yeah, that doesn't seem like a good idea.
Well, this is general practice, right? You want to see in the inside. This is what happens on the inside, right? So then you've got these brands going, oh, okay, well, you've taken me out for a meal and you're my drinking buddy now. I trust you. Let's do some business. We've had a great time. And stupidly, that's it's a relationship business, and yes, you go to the factory, and sometimes these agents take you on these factory tours that are not even their own factories. They've just basically organized it so that it looks like their factory, and you don't know. When you go and buy something from someone, you don't go to your butcher and say, oh, well, where's your certificate of compliance? Where's your food, certification before you buy your steak? Nobody does that. And we do exactly the same thing with sourcing at a lower level, at a consumer level. Of course, when it comes to industrial level, and we're talking, top 500 companies, there's a process which they do, and they have their own engineers which follow with the manufacturer's engineers, and they go through that process of compliance and locking in, this is what we expect. And that's why lawyers are involved, engineers are involved, your agreements are possibly hundreds of pages long. The thing I want to point out with all of this conversation is there's a cost to that. Does that mean that you're actually going to get a better cable? Maybe not. Maybe you got lucky. Maybe you went to dinner with the right people and they showed you the right stuff and you got lucky, and yes, you won the lottery that day. But you winning the lottery doesn't mean that your customers will benefit from that. So there's a cost to compliance. So the ATC, it does iPattern test, and that's done per channel. So you can see an example on this slide of what a great iPattern looks like after equalization.
Now, when you say per channel, what do you mean? Just so that people
each of the TMDS pairs or the FRL pairs is measured using an iPattern individually.
So
or
each
concurrently.
or individually or concurrently.
Yeah. So you can do an iPattern test. The equipment costs about $250,000.
Can you explain a bit about why it's so expensive?
Because we're testing at extreme speeds. We're testing at femtoseconds of timing. The testing procedure is like if you went out to Audio World and you bought yourself the most accurate atomic clock, right, and hooked it up to your DAC. So that type of specification of equipment is very expensive. It's very expensive to set up. It's very expensive to actually set up the lab. And then these types of test equipments is not like a plug and play situation, right? So you've got a breakout board, and those breakout boards, you look at that piece of plastic with some metal bits on there, is completely balanced out so that there is, so it's not that there's no noise, it's just the noise from that board is exactly known. So in the calculation, we can calculate that out.
Right.
And that little board there is like $3,000 for a piece of plastic, right? But that's what it costs to do proper engineering, because what we're testing is thousands of cables, not, this lab is not designed just to test one cable. So $250,000 roughly per channel. And if you want to test all 4 channels concurrently, then you're at $1 million, which is what a lot of ATCs are, because they want to do things fast.
Mm-hmm. Because doing faster means you're saving money.
There's a lot, like, how many HDMI devices do we have out there now? We've got billions of devices, and billions of devices are all renewing every year. So the ATCs are frantic in terms of doing testing, because you can't just be an HDMI ATC. It takes you years to find the place, be compliant, find the engineering that actually understand what they're testing, and train the people up. It's a big operation. So, it's measuring tolerance and insertion losses, timing, capacitance build up. You can read all of this. So, compliant DC voltage. The other tests that are going on are things like physical connector dimensions. So
they really break it down.
Yeah, they test everything. They really test everything. And that kind of testing it's not impossible, but is extremely expensive to apply to your $5 HDMI cable. It's very difficult to justify why a $5 HDMI cable might have to be $12. And physically, when you look at the cable, hey, I don't see any difference. Our eyes are not microscopes. You can't lick it and go, oh, there's a bit of a charge. I've seen people do it. I haven't done it. I've seen people do it. So that kind of testing is extremely difficult. And when they look super impressive, and the cable jacket's braided, comes in a nice box, which, by the way, you throw out or you repurpose, you know. But most boxes you chuck out. Well, you're paying for that. You're not actually paying for the product. You're paying for everything that dresses it up.
Right.
That, from an engineering point, makes no difference. I'm talking about a specific measurable difference. Right. There are inherent differences, and I want to insult people. There are differences, but you need a level of equipment. And we've started talking about some of this equipment to be able to ascertain the differences. I think it's fair to ask people, you know, is there an inherent engineering difference? Can you explain to me the engineering behind this? Can you explain to me why your engineering makes a difference and others cannot? If they can't do that, then there's a possibility they might be making it up.
So is there any indication or certification that indicates that this engineering is being done, or this level of testing is being done outside of the ones being directly tested by HDMI and getting their certification?
So HDMI have a labeling
right, which we talked about.
Process. Yep. Which we talked about, and we'll talk a little bit more about a bit later. But every single HDMI cable should be labeled with compliant labeling. If you can't label it properly, I would argue that you don't know how to build it properly. So, you know, calling Eric Stephen doesn't work in a crowd, especially. So that becomes an issue.
Okay.
Go to hdmi.org. Remind people, go to hdmi.org. Find out if the brand that you're buying is actually an adopter.
Well, and every cable should have a certification number on it, shouldn't it? That's actually certified.
It should have. It should have. But you know, when you get that cable, how do you know that that label is not a photocopy of another label from somewhere else?
It's really sad that we're in a position in today's day and age that is a problem.
Yeah. So HDMI actually have done their best to do, you know, laser 3D stickers that are supplied to proper manufacturers. But when other people don't comply, and HDMI do have a process for catching people out, but it's only when they catch people out.
Mm-hmm.
And when you've got millions of cables being sold per month, it's very difficult to catch. You know, Will from HDMI, he doesn't physically, he's got people in China going around the factories. You know, Brad Bramey from HDMI, he puts all the documentation and the marketing and things like that to ensure that that people know. But people don't look at HDMI advertising. They look at shiny thing advertising.
Right.
And HDMI don't actually profit from this. They're kind of well, they do, but their profit margins are not the massive profit margins that allow them to do Coca-Cola style Times Square billboard advertising. And even if they did that, it's kind of like not really relevant.
Yeah. Okay.
So there's a huge gap.
Yeah.
So at the factory level, there are variations of this testing. So you might have heard of something called a bit error rate test, where at the factory level, a cable is subject to bit error rates. So it passes the signal at whatever the specification is, and it actually does that testing for some cables, for every cable, or for no cables.
So what you're saying for that testing is it's sending it and then seeing if the exact same data is received on the other end.
Yeah, whether there is any bit loss.
Yeah.
So at that level, there's an acceptable bit loss. So you might say, well, okay, if I'm losing 1 or 2 bits, not a problem. Other manufacturers might say, I don't care if I move 1,000,000 bits, as long as it's getting some signal, because this thing called error correction will fix it. So that's specific and measurable. And I'm only going to randomly measure one channel.
Can you explain a
Or
little
I-
bit about what error correction is, just for the people that don't know?
So error correction is the equalizer inside your TV
Mm-hmm.
that actually interpolates a lost packet.
It's guessing.
It
In a
it's
way,
guess-
it's an educated guess based on other data.
It's guessing, just like a video scaler is mathematically guessing.
Yeah.
So it's an educated guess. You
Yeah.
like you know randomly the green that you're trying to create in a tree,
Mm-hmm.
right? Not every single leaf is being recreated, but it knows based on the image creation, or you know that the audio signal, the vocal timbre, the quality that's being delivered is a constant with a voice. So there is a lot of information, and AI is truly creating some remarkable things. And as it learns, it's going to make equalization better and better.
Yeah.
So it's using these interpolation techniques to, as you said, Ryan, guess.
And to make sure that people understand, error correction is not something new or something that's specific to HDMI. One of the biggest players in error correction is Ethernet and network traffic, which it is not uncommon to drop packets, considering how long the traversal distances and things are and how many steps they have to go through. So this is not new. We are surrounded by error correction every day, and it is used in a tremendous amount of electronics and communication. So I don't want people to get the wrong idea and think that, oh, well, any level of error correction being needed is bad. It's not perfect, but you won't notice as long as it's underneath the certain threshold, I would say.
Yeah, the difficulty with HDMI, and we talk about it being real time. It's relative real time. With watching YouTube or whatever watching online, we were afforded something called the spinning wheel. With HDMI, there is no spinning wheel because the audio is delicately timed with the video, and more importantly, HDCP is delicately timed with that signal. You cannot have too much tearing, timing issues before that HDCP goes, actually, you're not even walking through the right door, right? If you're not walking through the right door, I'm just going to shut it.
Right. Yeah.
And then, no signal.
Yeah.
So there is a delicate nature. And the reason why like people say, well, why can't we just get rid of HDCP? If we got rid of HDCP, it would be no different to YouTube, right? People don't want mastering quality content being stolen. And we all, most of us want to do the right thing. We pay for content and, we want to experience the best, but not everyone is like that.
Mm-hmm.
And they want to copy it and they want to monetize it and steal. And that's what HDCP is. So ultimately, no HDCP, no good quality content.
Yeah.
No top class content. So just a little bit more about testing is that bit error rate test that's done is a selective test. And the thing with the bit error rate test also is someone might say it's a BER test, but they might just be testing at 10 gig. They're not testing at 18 gig. They're not testing at 48 gig, or they're not testing at 96 gig. So the test needs to be specified per cable, per channel. If they don't say that, then just assume they're not doing it properly.
Now, when you say they don't say it, where can you get that information from people? Because I know you can get it from the HDMI certifications, but do people publish their testing methodology and data? Are there manufacturers that do that?
Manufacturers generally don't, because everyone's using a particular platform.
Mm-hmm.
And the reason why it doesn't is because their name is not on the test.
Okay.
You go buy it from a third party. That factory, their IP is their testing with the CEC on there, with signed by Dat Tran, who's the ATC head of ATC.
So you're saying, if I'm understanding this correctly, that this is more of a conversation and testing methodology that's happening between the manufacturing level and the vendor, if you will, before it even reaches the consumer.
Correct. The consumer is unlikely to see any of this.
Yeah. And you're saying, to bring in a synopsis on this, you're saying that from that level, the testing that may or may not be being asked by the vendor of the manufacturer could increase or keep static or decrease cost based on the testing methodology and in-depthness that is done. So there's no way outside of the HDMI certification that goes on there with the serial number that you can go onto hdmi.org and look up for a consumer to be able to get this data, unfortunately. It's just something that you would hope from an objective vendor that is being done.
So the thing that we need what the consumer can get, or what the user can get, or what a professional integrator can get, is they can go to hdmi.org, they can find out whether the brand that they're using is an adopter. If they're an adopter, then they have an agreement with HDMI. And that agreement covers compliance, following the adopter guidelines, and producing proper licensed engineering equipment. That is a legal agreement. Without that, there is no agreement. You can do whatever you want until someone finds you and sues you. But if you have a legal agreement, then if you're doing anything wrong, they're just going to monitor you and slap you across the back of the hand. Go on.
So how quick and how aggressive does HDMI monitor this? I know we talked about it a little bit earlier, but if you have somebody that is an adopter, and then they're not following the rules, I mean, are they eventually kicked out of being an adopter?
They get shut down. They get denied. They can get denied manufacturing rights, standard, and all of their product confiscated.
Oh, okay.
There's millions of dollars of HDMI cables entering the US border on a regular basis that just go in the bin.
Oh, wow.
US Customs is all over it.
Or as much as they can be.
That doesn't mean that the product isn't compliant. They go for things that are labeled incorrectly.
Man, okay.
So there is a compliance process, but it doesn't cover every.
Yeah.
And it doesn't. And a brand might want to be doing the right thing, but because they've found the wrong manufacturing partner, and because we're all running businesses here, right? Everyone would just like the user who used to buy $300 cables, he wants to buy a $15 cable. Well, the manufacturer now has to go and find someone that's going to make it the cable for, I don't know, $8, so he can pay 20% for insurance, warranty, running a business, and then pay some commission, some shipping, so that you can buy it for $15. But when the product becomes $2, the volume and the squeeze is on, and the possibility of compliance becomes more and more narrow.
Right. Okay.
So the tests are random. So you've got to be careful in terms of bit error test. So go to hdmi.org. Number 2, find out if your supplier actually knows what they're talking about. Ask technical questions, right? Whether they're honest.
But who can you ask technical questions of? Because a lot of times the consumers don't. Oh, you're saying supplier as a vendor.
Yeah. Ask the the sales guy or ask whether the distributors actually understand.
Yeah.
And if they don't, then will they pass you on to someone that you want to get information? Are they going to get back to you with the information that you're asking?
Mm-hmm.
Right? And be aware that sometimes that takes time, because if you're asking a question, guarantee you're not the only person asking that question. Right. So, are those manufacturers for the industry? Are they educating people?
Got it.
And there are plenty of manufacturers that are honest, that make exceptional product beyond what Kordz, right? Because there are different segments. Kordz is we specifically tailored for professional integrators, but there are great consumer brands. There are great commercial brands, great IT brands, occupying that market. So just reach out. When we go down further from the bit error rate test and the voltage test, which effectively makes sure that all the pins are aligned correctly, there's a function test. So people might not be able to afford the BER test. They go to a function test where maybe a PlayStation and a TV's plugged in, and you plug it in, and if it works on that, then it's fine. But where that falls over is if you didn't buy a PlayStation and a Sony TV, and you bought you had an Oppo Blu-ray player with I'm just saying random brands here. Like, don't take those specific brands as problem brands or anything like that, because like an LG TV, or you got a Marantz AV receiver and you plugged it into a Hisense, or a Samsung or a Panasonic. That doesn't mean that those devices are going to work with each other, because the only test that was done on the production line is a Sony with a Sony.
Right.
Why is that not more standardized?
It's not more standardized because the factory cannot afford to buy every single sync device and every single source device and every single repeater device and test every single cable that comes off that production line and test it with every single port on all of those devices. If I asked you to do that, it would take you, I don't know, a week to test one cable. Even if it was all set up.
It'd probably take longer than that, just because you'd have to walk to all these different devices because there's so many.
Yeah.
Yeah.
And 100%, that is not going to deliver you a $2 cable because of the time.
Yeah.
So
it's acceptable risk.
Yeah. It's acceptable risk. You plug it in, it works. Fine. Right. So in the engineering, they might have a control room or test room, and in the engineering sample, they might have done that. But on the production sample, and the reason why I talk the production sample is because that's the thing that you're actually going to get. You're not going to get the engineering sample, of which they only have 5. You're going to get the production sample, of which they're making millions. And then when the factory gets really good and the brand comes along and says, we've been doing business now for 5 years, I want you to make it cheaper or I'm going to go elsewhere. The factory goes, oh, well, we haven't had too many issues yet. We can save some money by doing a random test. We'll just pick one cable out of every 100 and we'll run it on that TV, and that'll save some money. Yes, Mr. Smith, I can save you 2 cents or 5 cents. And then some time goes on. Situation has, acceptable losses. We've been, or factories get arrogant and they talk to their brands. We've been doing HDMI cables since the very beginning. We've been doing it since 2001. We've had no issues. So then they have no tests. And at that point, at no test, spot test, or even function test, the end user is the experiment. So it's kind of like, at what level are you engineering at? As a consumer, yeah, sure, I can go back to the store and go, the cable you sold me doesn't work. Buy it online. Well, it depends on who you buy it online. They might have an opinion because it costs them freight to pick it up. Make it difficult for you. And you go, it's only a $2 cable anyway. I'll just put it in the bin, buy another one. But when you buy another one, it could fail again and you just repeat this process. Or you could be a professional. And when you're a professional, you buy that $2 cable, you plug it in, it doesn't work. It spoils the whole system. Remember, we talked about the HDMI error as being additive into the system. Well, now you got 20 HDMI cables in your system. Which one is it? Well, of course, it's the cheap one. Oh, well, I've got 5 cheap ones. But they're all variable depending on the test. No one's actually looked at the compliance aspect of it for you. And you've just got your client shouting at you over the phone, telling you this $100,000 system that you put in is an embarrassment. I pressed play in front of my friends and the thing didn't work and they all laughed at me. What is that worth? I mean, it's worth a lot to the client when he was going on an ego trip and just trying to be the best, the smartest guy in the room. So there are different expectations, which causes different problems. And all of this can be solved with money. If it's a money problem, you just pour money into it, you pay a little bit more. So just a quick summary of that is, well, make sure they're an adopter. Make sure that they know what they're talking about and you're getting it from a good source. And worst case scenario, that they're going to help you out.
Okay. Before we continue on with our discussion on HDMI, a quick word from our sponsor.
This episode is brought to you by the Martin Logan Dynamo and Abyss series subwoofers. Packed with high output, high precision aluminum cone woofers, powerful amplification, and ultra precise DSP, these subwoofers deliver deep controlled bass. They're built to perform and designed to fit seamlessly into any space. Martin Logan, bringing you truth in sound since 1983.
And welcome back as we continue to talk about HDMI. We're really getting into the nitty gritty, or starting to, with air testing at the manufacturing level. And this is something that a lot of people don't think about with how manufacturers are actually going through and certifying or testing their cables. Really not certifying, but testing their cables to make sure they're doing what you're asking of them. And it's been pretty interesting up till this point. We're getting now down to spot testing and now no testing. So I'll turn this back over to James and we will carry on with the discussion.
So quickly to the next slide, we'll rapid fire these next few ones. So a reminder on labeling. The question here is, do you have HDMI 2.1 cables? And if we'll go to the next slide, it will tell you, well, there's actually no such thing. The specification has specific ways to label HDMI cables. And on slide 22, you can actually see the correct labeling. So these are the only proper ways to label an HDMI cable. If the HDMI cable is not labeled this way, I'm missing one. One is called a premium, which is an optional test. All of these other tests are mandatory tests. So the HDMI cable that you need to buy has to have this label. And the 4 logos on the bottom, they can, if people want to use cheaper labels and not colored labels, and yes, that makes a difference to the cost, they can be black on white or white on black, or these colors. That is it. You cannot use any other color. And then the UHS and the Ultra 96, which is a new label, must be like that, supplied by HDMI, applied to the product by the manufacturer. When you scan that QR code using the HDMI.org app, which unfortunately you have to download, it's not scan the code and it takes you to HDMI's website. Extra step of confusion.
Yes.
But when you scan that, it will actually show you what length of cable that you bought and the manufacturer, not the factory, the brand. And if you scan that code and tells you, and I've caught people out, right, where they've got a 20 meter cable, and when you scan it, it's actually a 2.0 meter cable. And what that means is the logo is actually being supposed to be applied to a 2 meter cable, not a 20 meter cable.
I've actually
But
seen
in your
that before.
excitement, you go, oh, it's compliant.
Oh,
It's compliant. I'm sure
So
that's
don't
exactly
fall
what
into
happened. I'm sure that's exactly what happened, James.
um, so yeah, there's smart ways. So just remember these labels. So let's do some physical synopsis in terms of HDMI construction, and let's talk about HDMI cable pedigree. So this is a little exercise that you can all do yourselves, and I'm sure a lot of you have kind of made up Ethernet cables or used Ethernet cables by now because we're kind of into technology. HDMI has been around for a long time, since 2001. So, in its 24th year, the way we construct HDMI cables has actually changed very little. Yes, there's been timing improvements. Yes, there's been termination improvements, but not all HDMI cables have improved. Go to the next slide. We'll look at Cat6 and we'll paint a scenario. So Cat6 cables have 4 twisted pairs, 24 or 23 gauge. Oh, just like an HDMI cable. I'm talking about TMDS and FRL lines,
Yep.
right? It's defined by an industry standard, just like HDMI. It supports 250 megahertz as opposed to gigahertz in HDMI. The most common practice for Cat6 is gigabit Ethernet, 200 meters, or 10 gigabits per second to 55 meters. So from this statement, we know that there is a massive drop-off when we go longer.
Yep.
Solid core horizontal runs, again, an engineering thing. We know solid core runs for high bandwidth applications is better because we have this thing called skin effect. Stranded cores are still used, but they're only used for very short patch cables. They're not used for long cables.
Backing up here real quick, James. What is skin effect? Because I know people are going to wonder.
So skin effect is something when the frequency of the cable increases, the signal tends to skim more along the outside. Just like a washing machine. When you spin faster, or the frequency is faster, your clothes are pressed more tightly to the drum and squeezes more liquid in. From a signal point of view, and there is a lot of science behind this. So, it's studied at Cornell and MIT, like many engineering material science universities have. It's part of electrical engineering.
Yeah.
Right? So it's not something that's just made up. The dielectric, which is the shield, the insulation on the outside, and the conductor is the contact point gets squeezed. So the perfection of that is very important in terms of like the way it's that it's used, and that's why we have exotic materials. And yes, it improves things, but ultimately it comes down to price. So you've seen a lot of applications where people use silver on the outside of the cable. If it's a solid core conductor and you're using silver on the outside, it depends on your signal. So if you're dealing with only very, very high frequency signals, then a thin layer of silver, say 2% roughly, is fine. But when you start to use that cable for 720p applications, or you've got an older device that you want to run, well, the signal is starting to spread across that wider gap. And that silver copper boundary starts to cause capacitance and starts to cause different, and it's very, very minor, right? Different transmission frequencies.
Yeah.
And that's why silver cables sometimes have caused issues in the past. Now, take that to a stranded cable. Where is all the silver on a 2% stranded cable? It's on each of those individual cores. most of the silver is actually on the inside,
Yeah.
right? It's crossing over. It's jumping from copper to silver to silver to copper to silver, inside, because I want to travel. If it's skimming on the outside, 2% silver on a very thin cable is almost no silver at all. The other problem when I've added silver is I made the cable stiffer. So it's more delicate. It's more difficult to use. It's like I can't get it from this component to this component. I now need to put this player down here. And I've got this big loop that I need to adhere to. Otherwise, I'm damaging the cable. You've got additional things like insertion loss that's created when I plug the cable in. The cable's trying to do this. It's trying to lift the socket off the board. It's all these little minute things. And it's only a problem because we're transmitting at such high frequencies and we're delivering so much information in such a short time. And these are all additive things.
Yeah.
Yes, there's EQ, there's buffering, there's all these things to try and fix it. But if we preserve as much of it as we can, then it makes the equalization easier, which means the EQ doesn't run as hot, which means the capacitance within the equalization, the EQ device doesn't run, that doesn't happen as much, which means we preserve the signal as much as we can, which means the components run cooler, we get faster switching, all of those kinds of things. But the important thing is stranded core conductors. We use stranded core conductors because it has better flexibility. Okay. Yes, you can use stranded cables, but make sure it's a single material, copper, which is very high cost. It's very cost effective for the transmission that we're doing.
Now, you do have a sacrifice when you do that, stranded core, I'm assuming, because you're increasing potential attenuation, as says the next
correct
line here.
Yeah. So why do people use stranded core? Because they're handmade. It's very easy to solder a stranded cable, whereas it's very difficult to do that with a solid core cable. So people who are using solid core, making solid core HDMI cables, have, generally speaking, higher engineering knowledge and capacity.
So it's acceptable risk and a decrease in potential performance for ease of use. You're compromising to gain something else, effectively.
Correct.
We talk about this all the time on my other podcast of everything is a compromise. And in this case, you're compromising on performance for on-site effectiveness and being able to terminate, among other things.
Yeah.
Okay.
Yeah. The moment it leaves the instrument, guitar, piano, voice, drums, the moment it does that, there is loss.
Yeah.
So okay. It's just maintaining that pipe. All right. So if we go to the next slide and give you the first challenge, take 5 lengths of 200-foot cable, cut it as best you can, terminate them identically with the same connectors, and sweep each one for bandwidth. What do you think is the result? What do you think is the likelihood of you getting an identical signal out of every single one of those cables?
Impossible to the infinite degree.
Now,
I think you'd be lucky to get within 5%.
Now think about that at the factory level, because that's what they're doing.
Yeah.
For every single HDMI cable that's coming off.
So how do you get around this? Like, what is it just acceptable in this case, and it's something we have to deal with more and more and more as signal chains get more complicated? Is there a limit to this?
There will be a limit. Working? There is a limit, and the answer to getting this work is the equalization, and the answer to this is certification, and the basics of this is correct labeling. So we've gone through a number of these kind of things, and will you ever be able to trust the supplier? Well, we kind of already do with our TVs, right? Like HDMI cables have gotten better. Right?
Yes,
they have gotten better, and this is a clue for everyone here, right? They have gotten better for 1080p. I don't see a system for 1080p that doesn't really work now. Okay, if you're 1080p at 120 hertz, right, different, right? But if you're 1080p at 24 hertz, 4K 24 hertz, it's getting pretty good.
Yeah. Are you?
4K, so inside scoop, right? 4K 420 reliable. 4K 444
Yeah.
less reliable.
Yeah.
Twice the bandwidth requirement at 444 as opposed to 420. If your source material is Blu-ray, why are you operating at 444? What are you preserving when Blu-ray has been put onto the disc as 420?
Now you say that TV manufacturers or display manufacturers are, we've gotten to trust them, but is there in some sense, and I'm not putting the blame on anybody, but is there in some sense a false sense of trust there? Because I think it's not always the cable's fault.
It's not always the cable's fault, but unfortunately, it's more likely that it's the cable's fault than not.
Yes, but I think what I'm saying is go to the people watching is make sure you at least go into this with some caution in the facet of just because we're talking about the issues that HDMI and HDMI cables present, it does not mean that it is always the root cause. There are other variables at play here, and you want to make sure that everything is taken into account, not just the cable, because there can be untold numbers of issues that can exist on the source and sync side and not just within the cable itself.
And a reminder on one of the earlier slides we touched on, not slides, earlier HDMI episodes we touched on. For everyone that's listening, if you're just going from an Apple TV to your TV, you don't really have to worry, right? But if you want one Apple TV into all your bedrooms, and you're going through a splitter, and you're going through your AV receiver, and that's going through audio splitting, and you're trying to cheap out on the device and run multiple cables to every room, and then multiple video in the room, and you want synchronization to happen, you're creating complexity that is going to cost you time and effort. If you're just playing, no problem, go for it. But if you're engineering and you're trying to make reliable, it's never going to happen.
Well, I don't think it necessarily needs to be that complicated in order for it to not be reliable. I mean, you can get some pretty heinous reliability even with some pretty simple signal chains when you start including certain devices and cabling into the spectrum. So it can fall apart rather quickly, but I do agree that if you're going as HDMI was originally intended to do, one source to a sync, and that's all you're doing, it can be pretty reliable.
Yeah.
But even if you introduce one more cable or you add an AOC where you're transitioning and changing and you're doing things, the more steps you start adding, the greater you're increasing your failure vectors, and things can rapidly go out of control.
Okay. Well, let's talk a scenario where it's a fairly simple and common scenario, right? Where you have 4 displays. One for the master bedroom, one for the guest bedroom, one for the barbecue area outside, one for the living room. 4 displays, right? You got a splitter. You got a 3-meter HDMI cable to your living room. You got a 20-meter cable to your master bedroom, and the guests are pretty close to the living room, so that's like a 3-meter cable on the back wall. But you've got a 100-meter cable to your barbecue area.
Yep.
Right. The system works normally, and you discover, whenever I have guests and I'm entertaining, the system falls over because the TV in the barbecue area is not often on. When you turn it on, and it's doing HDCP, because you want your ESPN on all 4 devices.
Yep.
They all have to handshake. And when this 4th TV, which is part of the circuit, does not handshake, HDCP is not completed, and these 3 TVs no longer work.
Yeah. That
is an intermittent problem, because unless you really think about it, until you go back to basics and ask the client, well, when is the system not working? The client's going, well, I don't know. Whenever I have everything on.
Now, to
What does everything on mean?
be more specific about that question, you're talking about mainly because that cable is so long, it's changing the timing that HDCP has to authenticate.
Or it's not even completing the timing
Right.
because the cable's bad.
Okay.
And that cable is the cable that's the most difficult to remove and replace.
Is it bad in the way, like, let's say the cable is good. Is that cable long enough to create a timing problem?
No.
Didn't think so. I was just making sure that people understand the issue at hand. It's just you're saying that that cable may be creating problems that cause issues with the handshake.
Yeah. And
Okay.
it's a very simple, common issue, I believe, because you're not even using an AV receiver. You're looking at the system. It's just a splitter box. It's not overly complicated, right? And everything's just running at 4K, like low resolution. We're not trying to be 8K. We're not trying to push the envelope, right? And everything's into input 2 on your TV. So you've kept the system separate to the main input 1 local signal. But whenever and you've really got to think about it, whenever the barbecue area is on, the system fails.
Mm-hmm.
But until you step back and look at it and think about it, you're just thinking, whenever I turn everything on, the system fails. Does that mean TV 1's causing an issue, TV 2's causing an issue, TV 3's causing an issue, or TV 4's causing an issue?
You know, I've been in this industry a long time, and this pains me to admit, I've actually never thought of that particular scenario being an issue. And now that I think about it with all the HDMI things that I've banged my head against, that all makes sense. It's like you've just dropped the one piece of the puzzle that was missing, and this would have... sometimes all it takes is somebody from the outside just saying, well, what if it's this? And it's... Looking back, it's the simplest thing. Not that it's amazingly simple, but it makes sense given our conversation that something like that could screw the entire thing up.
But also a reminder that you need engineering backup. You've got hundreds of friends that have got experience in this.
Mm-hmm.
If they're all yelling at you, oh, what if it's this? All different. You just get more and more frustrated. Because you tried all those things. You know, I tried all those things. None of it. So get back to basics. So, okay, challenge 2. So we're getting a little bit long with this, but we're gonna try push through. Let's see whether we can get this done in 20 minutes. Okay. So challenge 2, same Cat6 cable, right? Find the best that you can. Terminate the RJ45s using your soldering iron. What do you think the bandwidth characteristics of this stranded, hand-soldered cable will be in comparison to the cables you made before? And can you define how much difference? Is it accurately predictable?
No, because the solder is going to change capacitance.
Correct. And the amount of solder that you put on each termination.
That, from my understanding, because Eric Bodley and I think you and I have had conversations about this, and Jeff and I have had conversations about this. Eric Bodley from Future Ready, Jeff Boccaccio from DPL Labs, and you from Kordz, about how even when you try and do breakout boards, one reason why yours are so expensive is because this is all accounted for. If you start making even minute differences in the amount of solder and joints and stuff, you're changing capacitance and thereby potentially changing timing and other variables that can throw things off when things are moving this fast.
Yeah. So a little bit of plug of my own business to explain something, but other companies use it as well. We use a particular solder that is stable, that is preheated, and is running at a constant temperature. Why do we do that? Because it controls the flow rate. It means that there's not some part which is more viscous than another. It means there are no lumps, which means when the solder is automatically applied to the conductor, we can predict the exact flow rate across all the different conductors, right?
Oh.
At the right temperature. And then the excess is sucked out with a vacuum. So then we don't have any excess. It's only what is applied.
It's amazing that you look at an HDMI cable and you think, man, what a simple, not that it actually is simple, but the construction, there's not a ton of components in it when you're looking at a passive cable. And then the amount of thought and intricacy that goes into even just a solder joint in order to ensure that this stuff works as it should is insane.
Yeah, it's $80,000 puzzle. That machine, which we have now multiples of,
Yeah.
It's an $80,000 problem that solves
But
an issue. So
to do it correctly, though, you have to do what you're doing.
yeah, even the orientation of how the HDMI cable goes in makes a difference.
When you say it goes in, what do you mean?
Yeah, so the cable goes in vertically. You can't have the solder kind of like pool on the bottom.
Oh, yeah.
So the final piece of the thinking with this is HDMI cables have a thinner gauge. Like the really thin HDMI cables are 34 gauge. A Cat6 cable is 24 or 23 gauge.
Yeah.
And yet an HDMI cable needs to deliver 100 times the data rate in a real-time unbuffered application.
But when you think about the things that we've been talking about, having the gauge that thin can be potentially, if my thinking is correct, beneficial depending on the distance.
Depending on the distance.
Yes.
But that manufacturing that needs real accuracy. Because when you talk about conductivity differences,
yeah,
right, the percentage of solder compared to the percentage of copper becomes greater as the gauge becomes thinner. And that's why when I say with manufacturing, if you go half the size, it requires 4 times the accuracy. To do 4 times the accuracy, you need equipment that's 4 times the price. Very roughly.
Yeah.
Right, as an engineering problem, right?
So how does Ethernet get away with this? Is it just because of the data rates? They don't have to worry about it as much? And it's not a real-time interface? It's buffered?
It's buffered.
Yeah. Okay.
It's buffered and it's using much thicker cable and it's got much broader tolerances, which allows for site termination. Why do we still not have site terminatable HDMI cables?
Because of the things we've just talked about. Yeah.
Because it's not really.
Can you imagine the mayhem that would unleash if that was something that was done?
Yeah. I mean, look, I hated re-terminating VGA cables.
Yeah.
You know, remember VGA?
Yes.
Right, 15 pins. It was a nightmare. And if you applied your soldering iron on one of the pins for too long, that pin just went what? Right. Okay, next slide. Okay, so we basically talked about this, right?
Yeah,
100 times the data rate. HDMI cables still use stranded copper. Most, some use solid core. You've got your length issues. You know, you've got your testing issues. So, you know, I won't go into that any more than we have to. So let's look at what is inside an HDMI cable. We talked about the theory of it. Let's look at what's practical inside. I've taken some photos of inside an HDMI cable. and this is a very, very popular brand that is very popular globally. It's sold in a lot of retail locations, and this is what you get for your $100 to $150 retail, right? Very large
size?
Connector.
Did you light it on fire?
Reference?
Sorry, say again.
Did you light it on fire?
No, I just cut the connector off. I cut the jacket off. So I mean, I have another HDMI cable, so I can point at things. But you know, this is typically what you buy for $15.
Mm-hmm.
And it's really no different to this $100, $150 one. It's a very large connector, makes it very big. This came from when thicker is better. So a thick cable going into an HDMI connector, which is not great, which has a very weak anchor. I'm sure we've experienced HDMI cables where we've bent them and the pins actually come out from behind.
Mm-hmm.
That's one of these. What is the temperature of solder when we apply solder? It's around about 187 degrees, right? Celsius. I don't know what it is in Fahrenheit. When we injection mold something, it's vastly higher. So why would we injection mold over our solder joints with no protection? Why would we deliberately cause delamination and dry joints? Well, because these are not cable manufacturers. They're not engineering people. They don't understand the connections. It's like you've baked this pizza, it's come out perfect, and then you just decide to run it in the oven again.
Now, would these issues cause it to not pass the HDMI specification?
No.
So no as in it wouldn't pass, or no, it doesn't matter?
No, as in they just need to supply the one that they worked.
Oh.
HDMI.
Yeah.
And then everything else is a self-test.
Okay.
And the other important thing is that there's no shielding. There's no foil wrap around the actual connector. Where is the most noise in an AV cabinet? Right where the equipment is.
Mm-hmm.
Not where the cable is. The cable's in the wall. Okay. You've done the right thing. You haven't run it next to a power cable. So most of the time it's fine. But as soon as you turn the equipment on and you close the equipment door, all of that noise is now like a microwave oven bouncing in the inside, causing all these issues. Oh, the system works if I leave the door open. Well, now you know exactly why. Because there's no shielding on your cables.
You said the era of thicker cables. Was it easier to get away with thicker cables with lower data rates?
It was the thicker the cable, the more Ohm's law again. The thicker the cable, the less resistance.
Yes.
Therefore, the better the signal in general, in terms of the power of the signal. The more power I have in the signal, the more as a ratio of noise, it is less easily interrupted. There are other conditions.
Right.
But in the general rule of, talking grossly, the general rule of thumb is if I need to fix something, I throw more power at it.
Yeah.
If I throw more power at it, I've got more juice, I can get more output.
Right. But I was just wondering is it more forgiving at the lower data rates? Like, are the syncs more forgiving when they're receiving back when that was more prevalent, if like 1080p or 720p was the top signal that you could get?
Yeah, it was getting more of the signal.
But was it
getting
more
more of the
forgiving
signal
in that? Like your sync for voltage and stuff? Because it would receive more voltage. I guess I'm worried that you're going to get an over voltage at that point, or an overcurrent.
No, not in the early stages.
Okay.
Not until long cable EQ boost came in.
Yeah, I got you now.
Yeah.
So it wasn't really an issue at this point. Got it.
So if we compare that to, your typical good quality HDMI cable, this is typically what it looks like. So there's no injection molding. You can see that the joints. This is a much older. I'm not showing the latest Kordz generation because we've got proprietary technology in there. This is an older generation which you can still buy, where we've got an ABS over mold, so there's no injection molding over injection molding. So we're not applying heat. The ABS over mold is ultrasonically soldered, so the two pieces are vibrated together, so there's no heat on the solder joints once it's been applied. We have a proper cradle in the back, the clear injection molded section on the cable is to hold the cables in place so that there's no insertion loss with the actual conductor trying to leverage off the solder joint. We use a full copper shielding. The connector's gold plated. You can see on the side of the ABS over mold that the legs of the cradle are actually quite long, which decreases the leverage and makes it stronger. And we're one of the first HDMI cable manufacturers to have what we call an extraction force. So every single HDMI cable has a minimum of 1 kilo or 10 Newton meters of extraction that you can apply before the cable disengages.
And disengages from the sink.
From the socket.
Yeah,
from the socket. Yeah. And then if you go to the next slide, this is an improvement, and it shows you all the different components of an improved HDMI cable. So we go to die casting, which means the socket is exactly the same. The internal support of the HDMI cable, we've got a wire manager, which actually holds all the cables in place, along with that clear injection that relieves the strain, but that injection also holds the twists all the way into the actual connector, so it's shielded all the way in. And then for superior shielding, we actually use a die cast shell which clips into the gold plated connector. So then that gives that whole connector over 20 kilos of force, like dynamic force without movement. And then there's a shell on the outside to make it pretty. But that's generally what we have.
Got it. James, thanks for talking about all of that with the process of manufacturing HDMI, the testing methodology, and how it brings everything together, and a lot of things that I have never really thought about. But before we say our goodbyes, a quick word from our sponsor.
Martin Logan delivers high-performance audio that fuses cutting-edge technology with sleek, elegant design. Engineered for audiophiles and home theater enthusiasts alike, Martin Logan products bring every sound to life with incredible clarity and power. Discover more at martinlogan.com and visit a dealer near you. Martin Logan, bringing you truth in sound since 1983.
And welcome back. We're just wrapping everything up on this topic of HDMI. We're going to have another episode. I think it's titled What Else Could Go Wrong, which is the one that I'm really excited about. James, thanks again for taking your time and doing all this. Eric, as always, thanks for joining us, and for AVS Forum graciously hosting. And thanks to our sponsor, Martin Logan, for being a part of this. And again, James, thank you for taking your time. I know it is very early in Australia where you are. And as we said at the very beginning of this podcast, you just got back from an event. You have staff setting up for another event, and we will be, I'm assuming you will be in CEDIA. All three of us will be, starting at the end of this week and next week. Okay.
No, I'm looking forward to exploring this further. And, if I get to see any members, you recognize me on the streets or, at a trade show, please come and talk to me, because for me personally, feedback is important for learning about what you guys are going through. And I am always up for helping you guys out. So please reach out to me.
The man, the myth, the HDMI legend, James Chen. But thank you again, gentlemen. And for all of our viewers, stay safe out there. Hope you enjoyed this show. I'm not sure we'll be following this up with this episode up immediately after with another HDMI. I think we're going to jump to projection and then come back to HDMI. We don't want to overwhelm you with HDMI. I know it is a riveting topic, but I think we're going to kind of segue into something else, then come back. But again, thanks for joining us. This is the Front Row, brought to you by AVS Forum and Martin Logan. We will see you guys in the next one. Have a good one.